This is Catherine Schmer at Chattanooga State Community College. This is video 3 of Planes in Space. In this video, we talk about the distance from a point to a plane. The distance from a point to a plane can be found by the formula d equals the absolute value of vector ps dotted with vector n divided by the magnitude of n. Now notice that this is the scalar component of vector ps projected onto vector n. So if p is a point on a plane with normal vector n, then the distance from any point s to the plane is the length of the vector projection of vector ps onto n. In example 3, we're asked to find the distance between the point 2, 2, 3 and the plane 2x plus y plus 2z equals 4. So the things that we need for our equation, or for our formula, are we need a point s, we need a normal vector to the plane, and we need a point on the plane. So 2, 2, 3 is our point s, it's just given to us. And to find the normal vector, we take the numbers attached to x, y, and z. So n equals 2, 1, 2. And to find a point P on the plane, it's easiest to find an intercept. So what we're going to do is we're going to let two of the variables equal 0. So we let x equal 0 and y equal 0. Then our equation of the plane just becomes 2z equals 4. From this, we can easily see that z equals 2, and so the point 0, 0, 2 is a point on the plane. So now we have a p, an s, and an n, and those are the three things we need to use this formula. ps equals the components of s minus the components of p, so the vector 2 minus 0, 2 minus 0, 3 minus 2. So ps equals 2, 2, 1. The magnitude of n equals the square root of each component of n squared and summed up. So the square root of 2 squared plus 1 squared plus 2 squared. That equals the square root of 9, which is 3. And now I'm just going to plug in my numbers to the distance formula. So the distance is the absolute value of vector ps dotted with vector n divided by the magnitude of n. So we have 2 times 2/3 plus 2 times 1/3 plus 1 times 2/3. So we just multiply corresponding components together and add them, add the results. So this is equal to 8/3. I would take the absolute value if necessary, and that would give me the distance from point S to the given plane. So whenever you're using this formula, find S, find N, and find P, and then just use the formula to figure out the distance.